Hello everyone. As far as previous lectures are concerned, we have covered types of network protocols, the role of operating system as far as networking is concerned, then client server, their definitions, then the different communication model like peer-to-peer communication and client server model communication, and how to establish a network between two pieces. If you are successful to establish a network between two PCs, then you will be able to establish the network among different types of or n number of PCs. Okay, so today our session will include the following points. That is, what is exactly the host is, what is subnet, what's the difference between that, then what are the different bandwidth consuming users as far as network is concerned. Then we will move towards topology and the different types of addressing. So let us start with this session. So let us start with this host and subnet. So now all of you give attention. So let us say in last lecture we have seen that there are two networks which are normally be discussed in our campus, that is LAN and WAN. So depending upon the distance between two PCs, the network can be a LAN, MAN, WAN or internet. Now for simplicity, let us say in our PICT campus, we have different LANs. Let us say this is E&TC department and its LAN, or let us say in our entire PICT campus, okay, these LAN indicates a PICT LAN. Then you consider another LAN which is a COEP college LAN. Then third is Cummins College LAN, and finally it is Sinhagad College LAN. So the boundary element of every LAN is nothing but router, and this router is normally situated in a server room. So all of you give attention. The boundary element of every LAN is nothing but a router. Thus, PICT College LAN and its boundary element this router. COEP College LAN and its boundary element is router. These routers are connected to each other to form a subnet. Please keep this in your mind. So basically, what are these? Uh, what is this a subnet? Subnet is nothing but the interconnection of all these routers, and on these routers normally different routing algorithms are installed and configured. So let us say I'm talking about PICT LAN, and if you enter www.yahoo.com, and let us say this yahoo.com to whom you want to communicate, it is in USA. Then from the different PC which is available in our laboratory, and that is communicating with yahoo.com which is there in USA. In that communication, several routers comes into picture. Let us say from PICT, when this packet leaves the router, it enters into internet. So this subnet is nothing but a part which is connected to internet through different service provider. Please keep this in your mind. Okay, so routers, different routing algorithms are there on these routers and they are configured. So a very simple host. Host is basically a part of local area network. So host LAN has a collection of machines intended for running application program called as host. So the different pieces which are there in your laboratories on which a Word is installed, a MATLAB is installed, Xilinx is installed, or different softwares which are required, C++, VB, VC++, and so on. Okay, a browser, okay, they are part of host. So please keep this in your mind. On host, operating system and different system softwares or different applications program, they are installed, configure, and they are running. Whereas as far as subnet is concerned, subnet is nothing but a interconnection of different routers. So this is what defined over here, the collection of communication lines. So these are the communication lines, and the routers, these are the routers, but not host. So subnet will not have a component that is called as host. Thus, the collection of a communication lines and the routers, but not the host, form the subnet. These lines, they are also known as circuits, channels, or trunks. Okay, and as far as router is concerned, how to define the router? Router is nothing but a switching element. Okay, these are the specialized computers which are used to connect two or more transmission line known as packet switching nodes or intermediate system, known as, or as a generic term we will call it as a router. This is what the definition of router. Now you must have understood that as far as LAN is concerned, the host, they are a part of LAN, where the different operating system and application system softwares, they are normally installed on this host. And whereas router is nothing but it is a part of subnet, where this system software or application softwares, they are not installed there. The routing algorithms or routing protocols are installed and configured on this router. Now, different bandwidth consumers. So whether it is a LAN, WAN, MAN, or internet, all the consumers on this network, they are defined by three specific consumers, that is unicast, broadcast, and multicast. A very simple a differentiation is given over here. Unicast. So let us say this is a network which is given over here. If this machine want to communicate with this machine, and it is not going to interfere this and this machine communication. So one to one communication, if you are transferring a data, see, whenever I'm talking about networking, it is nothing but a data communication. So as far as unicast communication is concerned, one to one communication, this is called as unicast. Specific user, one com to another com communication is known as unicast. Now broadcast, let us say this PC want to communicate with this PC. Though this PC want to communicate with this PC, the packet which is generated from this PC is going to this PC also and remaining PC also. Okay, so this type of mode is called as broadcast. Though this PC just want to communicate with only one PC, the same packet is being reached to each and every PC which is available on that LAN or on that network. So such type of communication system called as broadcast, that is one to all. And finally, multicast. If this PC want to communicate with a group of PC, then such type of communication is known as multicast communication. So stock exchange related codes, those who have registered and subscribed their subscription, so a group of different users are there, and in those groups, if they really want to send some information, then this multicast type of networking is used. So now I hope you must have understood unicast, that is one to one, broadcast one to one, but that packet is being broadcast to others also, so it becomes one to all. And third, multicast, that is one to a specific group of computers, so that is known as um, multicast. The network topology. What are the types of network topology? Now, before starting network topology, you have to understand that a topology is different and a technology is different. Technologies, let us say LAN technologies, we have listed in previous lecture. What are the different LAN technologies? Ethernet, that is IEEE 802.3, token bus IEEE 802.4, token ring IEEE 802.5. So these are called as network technologies, and one of them is always used in your laboratory or in your campus. So let us say our lab, DSP lab is concerned, wherever your ITCCN practicals are being conducted. So what type of technology is there? The technology which is installed for LAN communication, the technology which is being used, or LAN technology which is being used for this data communication, is a Ethernet, that is which works on the principle of IEEE 802.3. 3, and CSMA-CD protocol that we will see whether it is using CSMA-CD protocol or full duplex switch Ethernet. But right now, keep this in your mind that uh, technology is different and a topology is different. So let us start with network topology. Network topology indicates how the computers are connected physically. That's all. The layout which indicates the connection of computer is known as network topology. So very simple definition of network topology is, see this, the way in which the connections are made is called as topology of the network. Network topology specifically refers to a physical layout of network, especially the locations of computers and how the cable is run between them. It is important to select the right topology. Each topology has its own strength and weakness. And finally, the types of topologies are bus topology, star topology, ring topology, and mesh topology. Please keep this in your mind. So why I'm explaining all these things? So very first thing I told you that there is a difference between network topology and network technology. So as far as this network technology is concerned, for LAN, different types of technologies I listed, and one of them, that is Ethernet technology, is used in our campus. But as far as network topology is concerned, now after this session, you should be able to answer what topology is being used in our laboratories. So now, as the list is given, a bus topology, star topology, ring topology, and mesh topology. These 4 topologies are mentioned over here. Let us start one by one. Let us say bus topology. See this bus topology. Let us say these 4 machines are there. They are connected to a single cable, that is coaxial type of cable is there. And at the end, normally these T terminators are used. So such type of simple topology where these PCs are connected to a single wire, no switching or no hub is used right now for this bus topology local area network. So what is done? These 4 machines with a coaxial cable, they are connected to another coaxial cable, and at the end these T terminators are used. So what are the advantages? So let us say A can communicate with B, B can communicate with C, C can communicate with D, and all these machines can communicate with each other. So what is the advantage of such type of bus topology? Number one, simple, reliable in very small network, easy to use and understand. Number two, least amount of cable required to connect computers, so it is less expensive. Number three, extension of bus is easy by joining a cable using a BNC connector, so more computers can be connected. So let us say A, B, C, D, and if you want to add a E computer, then you can connect that coaxial cable with the help of BNC connector to this main or master cable running from one end to another, which is terminated by this T type of terminator. Next, a repeater can also be used to extend a bus to boost the signal and allows it to travel a longer distance. Let us say these 5 computers or 20 computers are there in one laboratory, and if you want to extend this to another laboratory where another 24 or 25 machines are kept, so those 2 labs can be connected, or a network can be extended from one lab to another lab with the help of repeater, because Ethernet technology is normally used, and after a specific distance you need a repeater. If you don't use repeater, the amplitude or the power of the signal is going to be reduced to a level where these signals cannot be identified or cannot be recognized by the processors which are connected to that network interface card or LAN card. So that is what the network extension. If you really want to extend a network, then you have to take care that after a certain distance, you have to use a repeater from one end to another end. Next, what are the disadvantages of this bus type of topology? Heavy traffic or network traffic can slow down a bus considerably because any computer can transmit data anytime. it uses the entire bandwidth and interrupts each other instead of communicating. So this is the major problem of this bus topology. Each barrel connectors weakens the signal power. So as I told you that these PCs are connected to this master cable using BNC connector. So as you go on connecting BNC connector, it is observed practically that the signal is going to be weakened if you use BNC connector. And third, it is difficult to troubleshoot a bus. A cable break or a loose connector will also cause a reflections and bring down the whole network, and network activity stop. So what is the meaning of this? If let us say C computer, if you want to remove this C computer from this network, at the moment you remove, okay, the entire network collapses because the connection is through T connector or sometimes with BNC connector. So because of this loose connection, normally such type of topology fails. Okay, so these are the advantages and disadvantages of bus topology. 20 to 25 years back, we used to use such type of bus topology where the single cable is running and all the machines were connected to this cable using BNC connector, and normally coaxial cable was being used. So this type of topology we were using 20 to 25 years back. Nowadays, nobody is using this bus topology because of the several disadvantages just now we discussed. Now, the topology, which is the famous one, the topology, which is the robust one, the topology, which is being used mostly in entire world is nothing but a star topology. Okay, so what is this star topology? A centralized hub is there, a centralized switch is there, and all these machines are connected. So in your laboratory, okay, you please recall that a central hub or layer 2 switch is mounted in your laboratory in one of the corner, and from that hub all the wires are connected to that 24 port or sometimes 30 port hub. So we are using 24 port hubs or switches or layer 2 switches in every lab. So from every PC the wire is connected to that switch, so that this ABCDEFG 24 machines are there, and 24 machine can be they can communicate with each other. So now description. Star networks, that is topology, are used in concentrated networks where the endpoints are directly reachable from a central location. When network extension is expected and when the greater reliability is needed, hub may be used. But nowadays, nobody is using hub. Hub is basically a layer 1 device which is less costly, but because of which the network slows down. Instead of that, nowadays everybody is using layer 2 switch, so the speed of communication increases and multiplexed data communication is possible. So now let us say advantages of this star type of topology. So just try to recall, topology just indicates that how the machines are connected. So centralized hub or centralized switch and all these machines are connected. So this forms a star network. So let us say a DSP lab, and if you want to extend this wire is connected to VLSI lab, this wire is connected to another lab, that is communication lab. So such type of network extension is possible. That is called as extended star type of network. Okay, so let us start with advantages. It is very easy to modify and add new network without disturbance or without disturbing the rest of the network. What is the meaning? Let us say this A, B, C, D, E, F, G, H, and so many 24 machines are connected to this layer 2 switch. If you want to remove this B, so though you remove this Cat5 RJ45 connector, with that connector you are connected with this layer 2 switch, though you remove this wire, rest of the machine and related communication is not going to be disturbed. This is the first advantage. Number two, center of the star is a good place to diagnose the network faults. If something happens, you just check whether the switch is on or off, or all these wires you can disconnect and connect immediately to this centralized hub. So any problem occurs, you have to check this hub. Number 3, with hub or layer 2 switch, you can use several cable types, that is UTP, STP, coaxial, fiber, etc. etc. So UTP stands for unshielded twisted pair cable, STP stands for shielded twisted pair cable, coaxial cable, fiber cable. If you want a gigabit Ethernet, then normally you go for fiber connectivity. So mostly use network topology is nothing but a star topology. Now few disadvantages are there. So in very first slide I told you that every topology has its own advantage and disadvantage. So let us say what are the disadvantages. If a central hub fails, the whole network fails to operate. As we have seen the advantage, center of the star network is good place to diagnose the network fault. But the disadvantage is also there, that if this hub or layer 2 switch itself fails, then all these 24 machines which are connected to this layer 2 switch or hub, they cannot communicate with each other. This is the first disadvantage. And number 2, cost is more than bus network, because network cable must be pulled to one central point, and accordingly the cable requirement increases. So wherever you keep the hub, from any point, wherever you have kept this PC, from every PC you have to run one cable and you have to connect it to hub. So accordingly hub should be placed in a central position of your laboratory or office, but the wire requirement increases compared to bus topology. So this is what the second disadvantage of star topology. But the star topology is very important, as I told you, because nowadays you go to any academic institution, you go to any IT based company, or you go to any company where the number of machines, let us say 100 machines, 500 machines are there, and they want to communicate with each other as a part of local area network communication, then you please keep this in your mind. Star topology is the best topology nowadays it is being used. Okay, and as I told you, a star and an extended star, sometimes this type of topology is also known as tree topology. So this star topology is mostly or most widely used topology in almost all types of campuses. Now we'll go for ring topology. The figure itself indicates that four machines here, they are connected with a ring. It forms a ring. That's why it is called as a ring topology. In ring network, each computer is connected to a next computer, with the last one connected to the first. So A, B, C, D. So last one connected to first. Number 2, message flow around the ring in one direction only. So clockwise, as I have shown over here, the data always flow in this direction only. Let us say D want to communicate with B. So D will not come in reverse fashion. It will communicate in one direction only. Since each computer retransmits what it receives, signal loss problems are there. There is no termination because there is no end to ring. Likewise, these are the four machines. Likewise, 400 machines can be connected to this ring. So what is the advantages? When more users are added, system slows down but doesn't fail. So then you can ask me how this sentence you can directly, or I can directly say it is observed practically, because it is proven mathematically as well as practically. So who has invented this type of ring network? IBM is the first company who has invented this ring type of topology, and they have their own patents based on this ring topology. Thereafter, at international level, it was standardized, and for token, such type of token uh, ring technology, they normally use this ring type of topology for the communication. So what is the advantages? They observed practically, when instead of four, if 400 machines are added, it slows down, but it never fails. So failure normally occurred in bus type of topology. Okay. Then disadvantages. Failure of one comp on the ring can affect the whole network. Let us say this B computer has some technical issues, and if you want to remove this comp from this a network or a ring topology network, the moment you touch this B and remove this wire, the ring is going to be break. It is going to be broken. And finally, there is no continuity and ring network fails. Number two, it is difficult to troubleshoot ring network. Okay, though it looks a simple, four machines are connected by wire, it's not a normal bus type of wire. There is a device in between they normally use, and from every device, okay, it is the wire is going inside and coming outside, going inside and coming outside, and finally it forms a ring. So such type of ring network is there. Then adding or removing computers disturbs the entire network. So how it is going to disturb this network, that you will study in next year, that is computer networks. So there are two solutions to solve this uh, wire break problem, as well as whenever you remove this PC from this ring network, there is another solution. So if the wire break is that, instead of one wire, you use another wire. Such type of network is known as fiber distributed data interface. That is one of the solution. And whenever you add or remove any new PC to this ring network, or whenever existing PC is, if you want to remove from this network, then you have to add, then you have to add one more device in this ring network, that is called as four wire centers. So right now it is not included or mentioned in your syllabus, that's why we are not going to cover that four wire center device here. So just keep this in your mind, that four wire center device can be used to add and remove the wire without disturbing this ring network. Next, mesh topology. Mesh topology indicates that every PC is connected to another PC. This connected to almost all. This is connected to almost all. This type of topology is known as mesh topology. Mesh topology. See this. Each computer is connected to other with a separate cable. What are the advantages? Guaranteed communication, high channel capacity. So one of the line if breaks, other is connected through another network. So let us say this and this. So right now it is directly connected. If this line fails, then this can communicate with this network. This can communicate with this network. So please try to understand this thing. What is the disadvantage? Difficulty of installation and reconfiguration. Since every PC is connected to another. So see this left side, this figure indicates, what is this figure? This figure indicates the mesh of wires. It is a mesh topology implemented, connected, and connection of almost 10,000 machines to each other. So please keep this in mind. See, these are the different wires in that exchange where 10,000 machines are connected to each other. So what is the problem or disadvantage of this? Difficulty of installation and configuration. So let us say if this one of the wire breaks, so which wire is connected where? It is very much difficult to, of course there are coding techniques and different labels are applied on those cable, but see, just look at this wire mesh. If any problem occurs, then definitely it is going to be a hectic work to find out the problem. Number two, maintenance cost. Definitely, it is obvious that if the wire mesh is like this, and if any problem occurs, the cost of maintenance is going to be high. So where exactly such applications where this type of mesh topology is needed? So such type of application is nothing but military application. Demand assign multiple access in broadband satellite networks and used in WANs to interconnect LANs for mission critical networks such as those used by governments. So if any problem occurs, or let us say if the war is going on in this military application because of bombarding and all this thing, one of the intermediate device or related network system is going to be damaged, then another backup network should be available so that important message from the higher authorities in the military, so those messages can be reached to the person who is fighting for your country. So such type of military applications, normally this mesh topology is always implemented. So now we have seen four types of topology. So topology just indicates that how computers are connected to each other. It just indicates the physical layout, how these computers are connected to each other. So this is what bus topology, star topology, ring topology, and mesh topology. So which type of topology is used in our campus? In our laboratory, we are using star topology. As far as laboratory to laboratory extension is concerned, it is known as extended star topology. Now addressing. So addressing. So normally, let us say you are staying in your home. Only one address is there. Let us say PICT college. Only one address is there. That is survey number, a street number, a Trimurti Chowk, or a Dhankodi, or a pin code of 41104, and whatever number which is there as a pin code. So normally one address is there for PICT college. Please keep this in your mind. If you are talking about your home, only one address is there. But networking is concerned. Let us say, what is networking? As I told you, a data communication between two pieces. And whenever you are talking about data communication between two pieces, then so many addresses are required. So what are those addresses? So we'll start with this lower layer. See this. Any system on a network is represented by a protocol stack or network architecture or a reference model. So right now, let us say these four layers, a TCP IP layers are there. We will see ISO OSI reference model first, then we will move towards TCP IP communication. So let us say practically a TCP IP is being used nowadays everywhere, whether you are a part of LAN communication or whether you are doing LAN communication or whether your machine is participating in internet communication or WAN communication. So now let us say this is one system and it is connected to another system on a LAN or WAN or internet, whatever. So four types of different addresses are defined. Number one, at a physical layer and MAC layer, the host to network layer is there. It is known as physical address. This physical address is also known as MAC address, that is media access control address. Number two, at a network layer, a logical address is also known as IP address. At a transport layer, it is known as port address. Okay, and at the application layer, it is known as application specific address. So physical address or MAC address. See this, the examples are given. Physical address, it is also known as hardware address. It is also known as MAC address. Okay, MAC stands for media access control. So host to network layer, physical layer and host to network layer. So normally MAC address is defined. So MAC address is given by such type of number. It is basically a 48-bit serial number in which first 24-bit indicates vendor code and remaining 24-bit indicates a serial number. So what are the different vendors? The vendors like D-Link, Cisco, HP, and so on. Okay. Number two, logical address. Okay, at a network layer, you have a logical address. This logical address, another name to this logical address is known as IP address. Okay, for example, class A IP address, class B IP address, class C IP address. As far as this logical IP addressing is concerned, okay, here we have directly written these addresses class ABC, but the classification is not like this. Classification is like IP version 4 and IP version 6. So right now, these are the examples of IP version 4. So I will tell you in a brief or in short what is IP version 4 and IP version 6 in following a lecture. Okay, so right now just keep in your mind a logical address is at a network layer and it is also known as IP address. So IP address can be classified as IP version 4 and IP version 6. Okay, in IP version 4, you will find Class A, Class B, Class C, Class D, and Class E. Class D is being used for multicasting, and Class E is being used or is reserved for future use. So right now, only Class A, B, and C are only mentioned over here. And in every class, it is again further classified as private and public. Class A, private public. Class B, private public. Class C, private public. Okay, so we will see as and when time comes what is this private IP address and public IP address. Then next is port address. Port addresses are defined at a transport layer. Please keep this in your mind. So you might have heard about FTP protocol. So file transfer protocol uses port address is nothing but 21. If you use telnet, that is remote execution or remote login, it uses port number 23. If you are using domain name system, it uses 53. If you are using browsing, that is hypertext transfer protocol, HTTP communication between your browser and web server, then normally port number 80 is used. Okay, so such type of port addresses are defined at a transport layer. Please keep this in your mind. And finally, at an application layer, you use user specific address, or it is also known as application specific address. Okay. For example, JAISWAL at yahoo.com, JAISWAL at shriganesh.com, JAISWAL at gmail.com, RC JAISWAL at pict.edu. So such type of users which are created. So these users, they are normally defined as a part of application layer. So now very first, before showing to this slide, before coming to this slide in detail, I told you one thing, that as far as office is concerned, only one address is there. As far as PICT college is concerned, only one address is there. As far as your home is concerned, only one address is there. But a data communication between two pieces, whether it is a part of LAN or whether it is a part of internet, it always consists of four types of different addresses. Okay, and these addresses are must. Why this is required, we will see it in our next lecture. So for the time being, now we will see why these different addressing and addresses are required in next lecture. Thank you very much.